Okay, perfect. So I told you guys I was going to do a video on the jaw crusher that you can see here in the background. So this is going to be the start of it. There's some upgrades I want to do to it, so I'm going to start dismantling it and show you the components of a jaw crusher if you guys want to build your own. So what we have here, this is a 6x8. It's 542 pounds. And we have one of the main flywheels here. This flywheel is 16 inches and 2 inches thick. It's 113 pounds. And it has a tapered hub in it. So we're going to try and get these things off. As you can see, they slide off pretty easy. Do this without, there we go. So what we also have here, let me bring you over here closer to this so you can see what's going on. So here's your eccentric shaft, keywayed. Has two 2-inch self-aligning pillow block bearings, and here's the other flywheel. And I'll move this and you can see the action of it going up and down. That's kind of walking on the thing. This is your fixed jaw and this is your moving jaw. Down here in the bottom you have where your toggle plate hooks to, and then here is one of the flywheels. You can see it's pretty decent size. What I wanted to do for you guys is actually show you what it takes to make one of these, cost, both in materials and machining. Machining is going to be the big one. Just a quick overview, the eccentric shaft is 2-inch 1045, machined down with a 1/4 inch eccentric in it, so the center is machined off center, so it has that eccentric movement. With materials and machining, this shaft is $850. Kind of expensive. The machining for the flywheels are 2-inch thick, A36 steel. There's nothing interesting about them. The machining, the material for just the flywheels was $345 each. Not very cheap. Then the machining for the flywheels and the tapered hub, this guy right here, the second half of it's in the flywheel, that was $1,100 for that. Then with material costs, bearings, you're looking at a total cost of about $4,600 just in materials and machining. So they're not cheap, but if you can build one by yourself, they're cheaper than buying one. Another thing that you guys have to take in consideration is what they call the nip angle, and that is the angle between the fixed jaw and the moving jaw, and it's the angle between these two distances that is very crucial. That's between 25 and 30 degrees is what the standard, and that is to allow that material to process through, to be able to be held, to be able to crush and then shear, is at 25 to 30 degrees. Your toggle plate, this guy right here, and I'll bring you in, I'll flip this jaw over on its side, and I'll bring you in and show you where it goes. This is a very important piece to the jaw. So stand by. Well, I finally got it dismantled. Took a few minutes, but let me bring you in and I'll show you what we're doing. So here's your components. This is your moving jaw, toggle plate. This is your eccentric. I'll focus in on here and you can see how it's machined off center. You have your tapered hub, keyed, and you have your flywheels. Then in the body of the jaw, you have your fixed jaw, which is right here, your shell. And then on this one, I've made these. Let me unscrew these. This is so you can adjust your feed size of what you're going to crush easily. This will go all the way from a 4-inch down to 1 inch. Pull these things out. Okay, these little guys in here are spacers. This slides out. And then you can see how this is machined. You can see it better here in this arc, this 3/4 arc, which fits this. This is the toggle plate, and that rotates inside of that, giving that point. Let me go over to the whiteboard and I'll show you what I'm talking about. Okay. So we're doing this in my actual workshop, place I work at. The two things I want to discuss is, let's go over the nip angle of the fixed jaw and the moving jaw. What that looks like is, here is your fixed jaw. Let me draw that a little better. This represents your fixed jaw inside the body. Then over here is your moving jaw. This angle between these two is your 25 to 30 degrees. Let me bring you in closer so you can see that. That's your 25 to 30 degree between your fixed jaw and your moving jaw. Now your toggle sits into here. Mine sits down at the bottom, and it is going to mirror this. It's going to be at that same, either horizontal, 0 to 20 degrees. This is where it sits. This moves in an arc as such. As this jaw moves up and down, this toggle bar forces it to go into a eccentric rotation. And it's very important that when you set your motor up for these things, that this jaw moves almost like in an anti-clockwise position, because what you want is for this to act first and then to squeeze. So this is, the top's going to come in first as your, if you look here, oh, you can't see that, let me back up. Okay, we're back at the whiteboard. So fixed jaw, moving jaw, the one that's at an angle, 25 to 30 degrees between the vertical and the angle. That is the nip angle that you want to achieve. Your toggle bar, which will go into the bottom of your moving jaw, is going to be 0 or completely horizontal, or no more than 20 degrees off the horizontal, very flat. It's the toggle bar that allows your fixed jaw to move in an eccentric. Otherwise, if you don't have that, the jaw is just going to go up and down. It's just going to squeeze rock. It's not going to crush it. It's the toggle bar that allows that compression and shearing motion, which causes the rock to fracture. And that is due to your eccentric here, right? We have an eccentric shaft. This jaw is going to first come in on the top and compress, and when it starts, that's when this goes, your eccentric shaft is going to compress first, then it's going to push the jaw down, which is your shearing motion, and the pivot point is going to be down here on your toggle bar, allowing this, if you have a rock in here, it's going to allow this jaw to compress and shear that rock. Very important to have on any jaw. So again, 25 to 30 degree nip angle between your fixed jaw and your moving jaw, 0 to 20 degrees on your toggle bar attached to the bottom of your moving jaw. Okay, now we're going to go over the body of the jaw crusher itself. So here you have the main body, you have your sides, your shell, and your front where your fixed jaw attaches. Now this is a very important piece, and this is the weakest part of any jaw. The modifications I'm doing to this, I'm actually adding 2 more struts in here and 1 down here, and that is the reason this takes all the force that this jaw can push against that rock. You want a minimum of 1/2 inch. If you're going to build a jaw of any size for any durability, minimum of 1/2 inch. This is all 3/8 stuff, and I'm going to put, like I said, 2 struts here and 1 down here just to handle that force of that jaw coming in. Let me spin this around since we're low weight now. As you can see, this is where the shaft, eccentric shaft, sits. You have 2 fixed mounting points within this body that I'm making, and that is so there's a dedicated alignment of the moving jaw to the body and the fixed jaw. In the side back here, you can see the fixed jaw mounting, and these are your jaw plates, I guess you could call them. These are all made out of T1, which is a heat and oil quenched steel. It's a work hardening steel. And then on top of this is a, I don't know if you can see that, there you go. This is a hard facing. This is a chromium, cobalt, and carbide hard facing. It's mounted both at the top, in the middle, and in the bottom, and this plate is removable. This is your back support. This is also where the toggle bar hooks into and gives the back support, so it doesn't spread when you have those crushing and shearing forces. Okay, so we're back over here at our pile of parts. Here are your shims for your toggle bar, the backing for the toggle bar, and on the fixed jaw that doesn't move, and then here on the moving jaw you can see that opening there, and the toggle bar registers inside of there and it moves. It's got a grease fitting on there because this is going to be a high pressure, high wear area, so I wanted this to be able to be lubricated. Most jaw crushers on the big ones, this is a lubrication point. Others, this is just a common wear item and they expect it to wear out and have you replace it. So the dynamic of this jaw is you can see how it's built at a taper. So you have a flat face, and this is that 30 degree. This causes that nip angle for your 30 degree. This is with a bearing mounting. And this strut design allows for maximum pressure to be able to be back. This is all 1/2 inch B50 or structural steel, mounted against a 3/8 faceplate. Then you have 1/2 inch struts, 1/2 inch backing, and then your jaw plate itself, if you can see down here, is also 1/2 inch. These are 3/4 bolts. Here's another look at the other side, the other mating side of the toggle perch. You can see that cut into it to allow that toggle to move in there. Here's the flywheels. Here's that hub that this comes as a component that you buy. So another thing I'm putting on this jaw crusher, which is an important part, it's called your tension rod. Right here, you can see it. It's a spring rod, and it attaches to the bottom of your moving jaw, and what it does is holds constant pressure against your toggle plate and your jaw, so that if you get into some binding rock, it doesn't slap. It always keeps a nice constant pressure. Has a spring. This is a 400-pound spring that's sitting on here once it's collapsed, and it's going to move on a pivot so it can move with the jaw, as there will be some up and down movement. Like I said, this piece, to have these pieces cut out, was $632 for both of these pieces, and then machining and the hub was another $1,200. The bearings were $89 for the set. These guys were $130 for the set, the 2-inch high strength pillow block bearings. The shaft, piece of 1045, 2-inch 1045. This is 1 3/4 machined down. This shaft with materials and machining is right around $800. So all these components put together, you saw the first of the video of all of them put together, to have materials and the machining done for a jaw crusher of this size. This is 6x8. You're looking right around $4,500 to $4,700, depending on who you do your machining and how much of it you can do yourself. So let me turn you around here and I'll face your camera. So if you guys are always wondering why jaw crushers are so expensive to purchase, this is why. They're heavy labor intensive, heavy machining intensive, and it takes a lot of material to make one that's actually going to last. We're putting this on a stand. I'll bring you to the stand over here. I'll walk you through my shop. So this is the stand that it's going on. It's 48 inches wide by 60 inches long. The jaw is going to mount here. The 13 horsepower motor and clutch system is going to mount here. This is all 3-inch quarter wall tubing. That is 1.5 by 3-inch quarter wall tubing. Remember, this thing weighs 540 pounds by itself. All put together, it's going to be just shy of 1,000 pounds. So now that I got the jaw crusher back together, you can see the toggle plate in place where it goes, and I'll roll the shaft over and you can see how it's moving. That keeps that lower jaw in place and pressure, and all that pressure on the bottom jaw comes all the way back into here. And this is adjustable. You just pull these things out, these spacers out, and you can open up your jaw. But you can see how it pivots. And a big thing with these jaw crushers, I'll show you the motion. You always want to make them go to where it feeds. So I'm going to roll this anti-clockwise, and you can see the jaw come up and then roll forward. Comes up and roll forward. You don't want it going backwards like this, because that actually will pull the material back up and out of the jaw. You want it to roll it forward. This actually happens to be anti-clockwise on the shaft, so you get a forward motion on the jaw. So one thing I didn't explain is the max RPM on this jaw crusher is going to be about 300 RPM. So there's going to be some reduction pulley wise. It's going to be driven probably by a I'm looking at making my own 2-inch flat belt pulley, which is going to then drive the 16-inch flywheels, and that's going to be on a flat belt. You don't want to overspeed a jaw. You can break them very easy because you have that rotational torque from those flywheels. There's 226 pounds of rotational torque, and if it binds up, those are going to keep moving and it can break your shaft. So you want to be able to have it stall. You want to overpower it, or RPM, or horsepower. You want to have that nice balance. So I hope this answers a lot of questions that people had. I know I had them when I first started building these and couldn't find anything on them. It was a lot of digging on the internet and reading books. So yeah, if you have any questions or anything, leave them in the comments below, and hope you guys have a good day.